Hi there, welcome to DesignSpark Ask the Expert, where today we're going to be talking about machine vision. So machine vision is much more widely used now than it's ever been, but the applications are probably the things that are making machine vision stand out. So from industry through to agriculture, through to smart cities and medical, machine vision is making great strides, but it always comes down to connectivity. And today we'll be talking to 3M and we're going to understand a little bit more about machine vision. Hi, welcome to DesignSpark. Hi, David. Would you like to say hello to DesignSpark and tell us about your role at 3M?
Sure. Sure. Thanks, Greg. And thanks for hosting the conversation here today. So my name is Dave Nyberg. I'm at 3M in the Electronics Materials Solutions Division. I've been in the division for several years, and I lead the interconnect business, specifically focusing on our industrial automation portfolio that includes a variety of connectors and interconnect solutions. And in particular, I run the machine vision portfolio, and we'll be focusing on that today.
Fantastic. Yeah, so I'm really looking forward to talking about machine vision with you, also the standards and some of the applications. But let's start with a brief summary of the different type of machine vision standards. How do the different machine vision interface standards compare?
Yeah, that's a great place to start. So there's, we really focus on 3 or 4 different standards that are kind of the main standards within the machine vision industry. There's Camera Link. Camera Link is one of the oldest standards out there. It's been around for 25 years or so. In fact, 3M was an originator of the original standard back in the late 90s when it was adopted by A3, or what then was AIA. And really, robust standard. Think about that standard for Camera Link. It's like the typical cables we used to plug into our computers and connecting our printers and monitors, but it still has its place. A lot of med tech industry uses it. You can transmit up to 6 gigs. Again, very durable, robust, a lot of screw locks on the connectors. Still in widespread use today, and 3M continues to support. Then there's some of the more recent ones like USB 3 Vision and Co-Express, and those each have their place in the industry. USB 3 Vision, obviously USB 3, for power charging and everything, there's just a proliferation of USB uses. So the machine vision industry has certainly benefited from that. Usually shorter lengths, usually lower cost, but USB definitely has its place. Very easy plug and play type solution. Co-Express, on the other hand, higher speed, typically longer lengths, and Co-Express, a single cable for CXP12 is 12.5 gig, and a lot of camera makers do a version of their cameras where they support a 4X bundle of that, so you can get up to 50 gig on a certain interface there with Co-Express. So Co-Express is probably one of the most widely used interfaces in the world. And then there's finally GigE. GigE Vision is another popular standard. What really sets GigE apart is the long transmission distance. If you need 100, 90, 80, 90, 100 meters, GigE is your solution. The trade-off is the speed. That interface has a slower speed, up to 1 gig, 10 gig with 10 GigE standard, but that's the trade-off. Longer length, less data capability.
Yeah. Yeah, there's always a trade-off somewhere, isn't there?
It does seem that way. But, the industry supports all these interfaces, and that's exactly why, because the users, the camera manufacturers, you've got a wide variety of there to choose from that meets the needs of the industry.
Yeah. So is it safe to say then that for machine vision interface standards, 3M supports most of those then? Yes?
Yeah, that's correct. We don't have GigE at the moment, but all the other 3 we fully support. In fact, like I mentioned with Camera Link, that's our oldest standard we've supported since we were part of the originators back in the late 90s. But a very robust portfolio there. More recently, we've entered the market with our USB 3 and Co-Express portfolio, and we're continuing to build on that with new product introductions that we did this year and planned next year. So we're very excited to be in broadening our portfolio in machine vision.
Fantastic. Just on 3M's machine vision cable assemblies, for example, what values are they bringing to customers, do you think?
Thanks for asking that question. Yeah, the Camera link, I think, we've sold that standard for so long. We're known for durability, value, and robustness of those cables. I just had a meeting with a customer last week. They've used their cable assemblies from 3M for over 20 years. They're still functioning very well. They mate and unmate just fine. I mean, they're just really durable, robust, high quality cable assemblies that we're known for. When it comes to the newer portfolio of USB and co-express, what really sets the 3M cable assemblies apart on the USB side, we have a lot of angled connectors on the camera side. We have screw locks, allowing for really tight industrial type connection. And with USB, we offer some of the longest lengths of passive cables in the industry, as well as high flex. There's, a lot of these cable assemblies are mounted on robotic arms. They have a lot of movement. They are in a really tough environment with a lot of stress. And our USB cables, we have a series of USB 3 cables that are tested for over 100 million cycles. And, that it's been tested for several years. It's going to keep on going. We may raise that in the future, but right now you have the assurance of a USB 3 cable from 3M for over 100 million cycles. And co-express, similar, longer length, obviously, but we've got a cable assembly for co-express, a series that's rated at over 45 million cycles. So durability and some of the angle features as well as length are key characteristics and features of our cables.
Yeah, absolutely. And some of the applications, obviously, that these are lending themselves to, like you mentioned, within those industrial environments, connectivity needs to be so robust. So when you're talking about 45 million life cycle, that's numbers, essentially that fail to compute with me. But, in terms of the life of the activity, that's years and years and years of solid performance there. There is an area I want to touch on. It's driving a lot of activity, obviously, with machine vision as well, is artificial intelligence and machine learning. They're constantly in the news on a daily basis. Whether you want to read about artificial intelligence or not, it just seems to seep through into our daily discussions. But in terms of, artificial intelligence, machine vision, how are they impacting each other?
Yeah, it's a great topic and very relevant today for anybody that's paying attention to the headlines. So, they go together because you think about artificial intelligence and machine learning, and especially related to machine vision. Those algorithms and processes, in order for the computers and machine learning to occur, there has to be inputs, there has to be data, and the imaging of the machine vision industry, the cameras provide a lot of that data, whether it's positioning or imaging of objects. One example is the 3D cameras are getting so good at detecting what an object is. We see in medical technology applications too, X-rays, pathology analysis, blood samples, for instance. High resolution image of a camera can now feed that data to a processor or computer host, and that's where the machine learning and the artificial intelligence kicks in to analyze that. And the speed is important, but what's also important is just the repetitive nature of over and over again. The machines, through machine learning, gets better and better through the iterative process. And you can imagine, like, to program and set some of these algorithms up, you have to literally give the computer thousands and thousands of samples to test, analyze, and learn from. And over time, it'll only get better and more robust. And all of that, again, is driven by a lot of those inputs of the images back to the host computer to process and do that machine learning and iterative process to develop those algorithms. And it requires more speed, more transmission capability, and that's really driving the industry to meet the needs of the cameras and the technology requirements to transmit that higher speed resolution, or higher data transfer rates, and more gigabits going through the line.
Yeah, it's such an interesting take on how artificial intelligence can actually, be of real benefit. You're talking there, obviously, within medical applications, but for industrial applications as well, quality monitoring, etc. What you were talking there about the repetitive use of the cameras you want them to actually, over time help in that kind of division of making artificial intelligence better. So what I want to talk to you about is you mentioned USB-free vision. What are the advantages or the differences when you were talking about USB-free vision compared to other machine vision standards, for example?
Yeah. Yeah, the again, USB 3, one of the advantages is relatively lower cost, fairly economical solutions. The length is a bit of a challenge sometimes, but if you have shorter lengths, then shorter distances to transmit data, it can be a really good fit. And the simple uh, connectivity options with screw locks and angled features. If customers, a lot of our customers, they have tight spaces they're trying to work in. They have a robotic arm where there's a lot of movement. There's movement 24/7, just continually on these processes, whether it's machine learning type processes or just robotic type automation in a factory. Constant movement 24/7. And the USB, when you have USB cables that are tested at 100 million cycles, it was like you were saying earlier, that it's going to last a long, long time. So you pair that with the ability for all that durability and the flex cycles, along with the screw locks and vibration resistant connections, really tight connections. You've got a real winning combination there with USB and those really hard industrial rugged type environments.
Yeah. So yeah, you were talking there about the length limitations for USB free. So how do you address that? The kind of long distance data transmissions that you would associate with industrial applications. What do we need to compensate for? Is there any advice you can give us?
Yeah, there are a lot of options on the market with active cables with repeaters, and they can certainly extend the distance. There's USB cables I think on the market that 30 meters is probably not out of the question. There's some trade-offs there with the data rate, and you do have to have some active repeaters in those cable assemblies to make it work. The trade-offs there, there probably is more maintenance. They're certainly more costly. They're not as economical as a passive type cable, but they can get the job done. And that's again, the trade-off. If you have a lot of interface standards that you're comfortable with that are USB, and you're a design engineer or a facility manager on a factory line, you may be comfortable sticking with that and be willing to do those trade-offs rather than move up to co-express that might have a longer transmission length, but you don't have all that redundancy and backwards compatible if you switch to that kind of interface. So that's really what drives a lot of the decisions is user preference. And just like you said earlier at the beginning, Greg, a lot of these different choices, but you give users a lot of trade-offs and a lot of options to meet a variety of their needs.
Yeah, absolutely. There's still a lot of things to obviously consider. You were talking about the rigors of industrial applications. So if we're thinking about USB free vision, industrial cameras, the cable assemblies, how do they themselves then help to compensate, or if we can talk about transmission distance against the rigors of the application. You did mention a couple of things previously, but I just want to focus in on that a little bit more, if that's okay.
Sure. Yeah. Yeah. I think the transmission distance is really key. And when you're talking about, gig E, for example, you can go 100 meters, but you're very limited on the data rate. And if you can't, if you have images that exceed that data rate, you really have to shorten the cables. That's where some kind of active
Yeah.
cables, or just a straight up reconfiguration of your. We see a lot of customers. The data rate is a challenge as their images and resolution gets higher, so they're trying to move the systems closer to where the action is, and that creates its own set of problems. If there's a tough environment where the actual cameras are located, can you really get the host computers and some of the servers and information processed closer to where the images are actually being taken? But that's another way to do it. There's a lot of ways to accomplish the same thing.
Yeah. Now there's a couple of things obviously with applications with with 3M, obviously you'll have insight into the applications of machine vision. And I'm just wondering, is there any kind of industrials, verticals that you can tell us, give us a couple of application examples that where we're seeing the growth of machine vision?
Yeah, I mean, it's widespread across a lot of industries, but there's the whole, semicon, for example, there's a lot of activity with semicon. I mean, that industry, if there's one industry where throughput and yield is just so much focus on that. And again, it's in the headlines all the time, the need for chips because of a lot of the things we're talking about, artificial intelligence, machine learning, autonomous vehicles, or just even the complexity of vehicles, and needing chips. Just everyday life now is so immersed in everything we do is tied up with chips and the connected life we have.
Yeah.
But those chips, the precision with which the semicon manufacturers are making those chips, you're talking about chips with process nodes down to the nanometer, and the QA/QC process, positioning on the wafer line. Some of these things require a QA process and cameras that the resolution is better than it's ever been to try and detect things and keep that factory line moving, so that when there's a defect or a problem, it's quickly identified, addressed, and the line keeps moving. And that industry, again, it's all about speed, it's all about throughput. You have to be up and running, and they're relying more and more on machine vision cameras in the industry to provide their QA as the chips get smaller, as the complexities of those chips get greater. That's a really good example. And the other side of that, semicon, you're in clean rooms, you're in a lot of really controlled environments. We have other customers like drone manufacturers, where you can't think of a more maybe rugged application. Obviously very short length. There's a small USB cable in the drone, but these drones crash. They have hard landings. They're exposed to the elements, UV exposure, rain, moisture, whatever it might be. That's where the screw locks, the tight connections with the USB, they really come into play. And again, another industry that's really booming, and we'll see continued growth in that space, I'm sure. Those machine vision, drone cameras now are better than they've ever been. They're transmitting data, they're collecting images with more resolution than they've ever done.
Yeah. There's a lot of different types of industry where I'm seeing the growth of machine vision, from agriculture through to pharmaceutical, through to process management, for example. But what I think a lot of people maybe don't actually appreciate and understand is the kind of vision that we are talking about, and the speed of the processing. Also, you've got the learning of artificial intelligence on top. But when you were talking about, quality management, for example, those vision cameras are really, they're operating at very fast speeds.
Mhm.
The data they're sending back is really great for things like the enterprise zone if you're in an industrial application, and throughput is an area that you're measuring, but the application for quality control as well. And you mentioned earlier about medical applications. That's one area that I was really interested in to do some research a couple of years back, and the growth of machine vision within those medical applications, where they were looking at imageries that doctors were looking at, surgeons were looking at, and they were picking up on things that, were well in advance of when things would have been traditionally diagnosed. So
Mhm.
I just want to maybe think about a couple of the future trends for machine vision, because back in my day a couple of years ago, when I was looking first at machine vision, the application potential just seems to have exploded. And I'm just wondering, from obviously 3M's point of view, and I guess, just let's call this out, connectivity is what you guys are all about. And connectivity, and that kind of quality of connectivity is what will define good machine vision moving forward. So I'm just wondering where you guys are maybe focusing. Are there any trends that you'd like to call out?
Yeah, there's many trends, and your medical one was a great example. We've got another customer that's using these just tiny microscopic cameras. I mean, the prevalence of surgical applications where the surgeon may not even be in the room. The surgeon, whoever's doing the procedure can actually be in another city compared to where the patient actually is. Even robotic surgeries are taking off, and all of those procedures, there's still an element of visual analysis, the human eye, something taking the place of the human eye that on a microscopic level has to see something in that surgical process. So that's a really good example. And you can imagine how important the transmission rate is in those type of applications. Same with radiology. I think I mentioned that earlier too. These X-ray images or CAT scans, the level of the image resolution, as well as the ability to detect what you're looking for. The medical community, humans were susceptible to fatigue, to repetition, to human error. These computers don't have that problem. They can run 24/7, and they're getting better with each iterative process. So we see a lot of that occurring. And then I think on the interface side, it's worth mentioning there's a lot of activity right now around this whole thing we've talked about around data speed. And there was just an IVSM, the International Vision Standards meeting a couple weeks ago in Switzerland. We had representatives from 3M there, along with a lot of manufacturers from around the world. And a couple of the topics on the table were increasing the machine vision standards and the speed, raising those speeds because the industry is so quickly advancing with needing higher speed interfaces. And even the trend we're seeing is moving to fiber optic. There's more discussion now than ever. A lot of these interfaces we've talked about earlier are copper-based interfaces, but there's a lot of discussion now of moving to fiber optic. And it's really back to what you said earlier, Greg, around the long distance. Fiber optic, the distance is really not a non-factor then. I mean, you and I are connected on different continents right now, speaking in real time because of the advances of fiber optic. And when you're talking 100, 200, 300 meters with fiber optic, that's really no issue. So I think that's a real trend we're going to see emerging here in the coming years is interface standards around fiber optics. I'm convinced of that.
Yeah. And I do also think, there's, whether you want to call it the stars are in perfect alignment, we're talking about things like, a couple of years ago, obviously, we were talking about 5G, fiber optic communication, data transmission speeds, etc. Now we're talking about adding AI into the mix, and then with machine learning and machine vision. I guess this potentially could go in multiple different directions. But one of the things which is kind of my thought process is that there's probably, and I'm just harping back to the medical application, there are probably people walking around today who 10 years ago wouldn't be. And it's all to do with this thing called machine vision and artificial intelligence. I think it's a fascinating subject, David. And I'd love to have you on DesignSpark again sometime soon. If we can continue this conversation, that would be great.
Yeah, I'd love to be here. And you're absolutely right. The medical field is saving lives. The detection level, the ability to detect disease earlier than ever is no doubt saving lives. And a lot of it's due to that imaging piece that you just mentioned. Yeah. And we're delighted to do this today and happy to be back anytime.
Yeah. Appreciate you taking the time out, David. Have a good day.
Okay. Thank you. You too.